Welcome to this Blender Kickstarter, and in this lesson I'm going to give you an introduction to RenderMan for Blender, and in no time at all we're going to get you up and rendering. So I've already installed RenderMan for Blender, and I'm not really going to go over that process in this video because I want to keep this Kickstarter quite concise and to the point. And if you want to know how to install RenderMan for Blender, then you can just look at the documentation online. And like I say, I just want to keep this lesson quite concise and to the point and get you rendering in no time. Now let me just show you what this scene consists of. I've got my robot here, and then I've also got a camera which I've set up here. And apart from that, there's nothing else going on in this scene. It's a completely vanilla scene. Now the first thing you need to do is you right click, and you can see here from this context menu that it says use RenderMan. So if I select it, now what happens is, because I've got RenderMan installed, it now activates RenderMan within Blender, and as you can see, a whole bunch of new icons have appeared, and we'll run through those as we go. So the next thing I want to bring your attention to is that we need to be rendering within the ACES CG color space. And for all you Blender artists out there, if you're not rendering in ACES CG, you need to put your Wacom pens down, and you need to make sure that all your projects going forward are always rendering within the ACES CG color space. And I've done a number of lessons on ACES CG, and if you don't know what it is, go on to the RenderMan website and have a look at the previous ACES CG lesson that I've created, because once you discover working within ACES CG, you'll never go back, because your renders will pretty much instantly look much more photorealistic. I've already set this up and I'm going to show you how to do it. So you can see here that in the Scene Properties tab, if I go all the way down to the bottom, under Color Management, I've got a number of things that have already been set up. I've got Display Device and I've got View Transform. So this Display Device, this tells me that we're running in the ACES CG color space, and also the sequencer is also running in ACES CG. Now, I'm on a Linux box, and the way you need to do it is you need to set an environment variable. And there's a number of different ways depending on which operating system you're running. But on Linux, there's a certain way, and on Windows, there's another certain way. And if I just show you here, what I'm basically doing is that I'm creating an environment variable called OCIO, and this is pointing to this config.ocio file, which sits within the RenderMan Pro server folder. And this is the path here that you can see. And because I use the RenderMan version of ACES CG that ships with the RenderMan Pro server, it ensures that if I'm running in Blender, or I'm running in Maya or Katana or even Houdini, it always ensures that I'm always using the version of ACES CG that runs with RenderMan. So my renders will always be consistent across all my DCCs. Okay, so now we've got that set up, let's have a quick look at some of the interface pieces that come with RenderMan. So here within the Scene tab, we have a number of render settings. So this tells RenderMan where to render to. It can render to the Blender viewport, or it can also render to it, which is RenderMan's image tool, and we're going to have a look at that in a bit. And so this next one here shows me whether I want to render with RIS, or whether I want to use the new GPU and CPU hybrid render called XPU. And again, we'll have a quick look at that in a minute. And then there's a whole bunch of other options here, but under the sampling here, this is where you define the quality of your renders. You have two separate sections. This first section here defines your final render image quality, and then this second IPR sampling here defines the minimum and max samples and pixel variants which the interactive IPR sessions run within. And then we have things like checkpointing, which enables you to render frames up to a certain time and then come back and then pick those frames up and then carry on rendering. And then we have other things here, so we can set the motion blur on and off, and then we have a bunch of advanced parameters as well that we can adjust. But we're not going to get too much into this today because, again, this is just a Kickstarter and we want to be quite quick to get rendering. And then up here in this viewport, we have this IPR button, and this will kick off a interactive render session. So the way the interface works is that it has two different sort of modes, that if you select an object and you right click, you can then add a material to it, and you can convert it to a mesh light, or you can add some subdivisions. And then if you want to do things like add lights, that's up here in this menu here. So you can come to add RenderMan light and then add a Pixar dome light or a rectangular light. And then you can then add filters. You can then do things like you can add a volume box, or you can import a VDB. You also have this little view tab here where you can pull it out, and under RenderMan here, you've got useful buttons that can load up the preset browser, which is really amazing because it allows you to create materials, save them to the preset browser, and then you can load them up in other DCCs. So if you make a fantastic metal shader in Blender, you can save it to the preset browser, you can jump into Maya, load up the same material, and then use that within Maya. Or you can work the other way. You can create an amazing shader in Maya, save it, and then load it up in Blender. It just really depends. But it's such a useful tool because it allows you to create presets of all your materials. So you can use them across projects as well. And it also ships with a whole bunch of presets. So these are really useful to get you going. So it's got various metals, it's got metallic paints, and it also has a bunch of preset stylized looks as well. And then here you've got a number of buttons to do the render. You can add a camera, you can add some lights and a filter. So this is a really useful little menu if you don't want to keep sort of jumping around the interface. So let me just close that down. Now, because this is the base scene, it's got nothing really going on in it. The first thing I'm going to do is I'm going to add the same material to everything. And then we're going to go through and change each material. So let me go ahead and select all by type and select mesh. And then if I right click and then I go create new material, you'll see here that we get a bunch of options. Now, we're not really going to have a look at all the llama materials, which was developed by Industrial Light and Magic. The one we're going to concentrate on for this lesson is the amazing Pixar surface. And again, if you want to have a look at how this Pixar surface material works, I've already created a whole bunch of lessons on the RenderMan fundamentals page on the RenderMan website. And you can work through all of the parameters within the Pixar surface and see all the amazing things that you can make with it. So I'm just going to select it now, and it'll go ahead as it has done here and apply the same material to everything within the scene. So just before we dive in and get the light set up, I just went ahead and got rid of some of the extra pieces of interface. And I also zoomed the camera in as well so we could see this a bit bigger. Now the way you add in an HDRI is you come up to add and you go RenderMan and then light, and then you want this Pixar dome light. Now let me show you how RenderMan works with its textures. We're going to add in a color map into this HDRI dome. So this is the map here that we're going to work with, and it's an EXR file. But what RenderMan really wants to do is it wants to turn all textures, whether they're HDRI maps for the dome light or whether they're PBR textures you've got from the internet. It doesn't really matter what they are, but RenderMan always wants to convert it to its TEX file format. And especially now in RenderMan 24, it also wants to convert it into ACES CG, which, as I showed you at the beginning, this is the color space that we're rendering in. So let me just show you how this works. If I load in this file here and I select this HDRI from here, now what happens is that RenderMan will load it in, but it'll also, in the background, it'll also go ahead and it'll convert it automatically to the .tex format. And if we give it a minute, you'll see what I mean. Okay, so that didn't take very long, and you can see here now what we've got is we've got this other version of the file, and you can see that it's got underscore ACES CG. We know that it's converted it to the ACES CG color space, and it's also got the TEX file extension to it. So we can see what it's done is it's taken this EXR file and it's automatically converted it into the format it needs. Now you don't need to touch this because even though it says EXR here, it is actually always referring to this file. So one last little thing before we get on with it, and I'm sure you're all shouting at the screen, please just show me a render. I just want to go back to the scene tab here, and I just want to show you the fact that we are currently rendering within RIS, and in a minute we'll have a look at XPU. And then you have these two other options here. One, you've got where you want your final renders to go, whether you want them to go to Blender or it, and you can also set here whether you want your IPR renders to go to Blender and it. And for the minute, we're just going to do it straight into the Blender viewport, and then after that, we'll have a look at it. Okay, so let's get on with it and press this little blue IPR button up here. And after a moment, you'll see that RenderMan fires up its interactive render session. So now that's rendering, let me just go ahead and adjust the light. So if I come to the light tab here, I just want to increase the intensity up to 4. And I know I tidied these away, but I just want to rotate my dome light around a little bit. Okay, so let me take that away. So now we've got some rendering going. So now let's go ahead and start to apply some materials to each of these models. So the first thing we're going to do is this background, this tabletop. So I'm going to select it and I right click and I go add new material and I add a Pixar surface. So that's added a new individual Pixar surface only to this background. So I want to add a texture to this, and I do that by adding a Pixar texture node. So for all Pixar nodes, you start by typing PXR, and then for texture, you carry on typing texture. And then here we have this Pixar texture node. And if I go ahead and take the output and then plug it into the diffuse color, you'll all freak out and go, oh my God, it's all gone pink. Well, don't worry, because what pink means in the RenderMan world is that it's missing the texture file. So if I come here and I select it and I come down to the material tab, you can see here that there's nothing in the file name. And so this missing color parameter here, this is what is alerting me to the fact that there's no textures here. So if you load up an old scene, for instance, and you press render and you get a lot of pink in it, you'll be able to go back and debug it and see if some file path has changed or if the texture's been deleted. So I've already made the texture and I've got a little scene to the left of me on another screen where I'm just cutting and pasting these textures in so we don't have to waste too much time. So I've pasted in this checker Aces CG texture that I've created. Now what I want to do is I want to adjust the tiling on this texture, and I do that with a Pixar manifold 2D node. So as with all Pixar nodes, you type PXR and then manifold 2D. And then I take the result out and I plug it down here into manifold. So now what this does is it allows me to start to change the number of frequencies that this texture is now being applied. And if I go ahead and adjust this frequency to something like 9 by 9, you can see now what this is doing is it's repeating this texture 9 times in the X and 9 times in the Y. So that's how you use a texture, and this is also how you then start to adjust it using a Pixar manifold 2D. Now I'm just going to adjust my viewport a little bit so that we've got a bit more space here. So let me show you these icons here at the top of this window. The first one here starts and stops the IPR. This second one here allows you to change the integrator which RenderMan is currently rendering with, and by default it's always at this path tracer, and in most cases I would always leave it at this default, but you can also have a look at other ones. So you can change it to see what the direct lighting is doing. You can change it to this default mode, which is also quite useful for debugging. And then you've got this ambient occlusion integrator. This Pixar Unified is what actually Pixar in the studio use, but we don't necessarily recommend it because it's pretty render intensive. So the next one here you have is Pixar VCM, which is really great for things like glass and caustics. But like I say, for most cases, you really just only want to keep it on this path tracer. Okay, so the next one here allows you to change the number of interactive refinements. So by default, it's at 0. And if I move the camera in and out, you can see that it does a good job. But then if I then come to say something like 3, it starts to do this refinement of the viewport as you move around. So if you have a heavy scene, you can start to change this up to something like 6. So when you're moving around inside the viewport, you actually get a result much quicker, and then over time it then starts to refine it. And I'll put that back to 0. This one here allows you to scale the resolution. So you can knock it down to 50% or 33%. And again, it'll render faster. You'll get a much poorer result. This is probably quite useful for sort of heavier scenes where you're trying to adjust the lighting overall, and then you want a sort of faster interaction. So you would knock this percentage down to something like 33. And then when you're happy with it, you can then bring it back up to 100%. This here allows me to look at the channel, so I can look at the alpha, and I can look at the Z depth, and I can also look at the ID. But at the minute, we haven't really set any of these up. So, and again, this one here allows me to draw a render region. So if you're working on a bigger scene and you only want to sort of refine a certain part of your scene, then this will allow you to kind of do that. And then you then can just close it back down again, and it releases the buckets for the entire shot. This here will do a zooming thing. So if you want to work only on this little bit, you can come here and you can refine this bit, and then to come back out of it again, you press the escape button. This is really useful at times because you may have your camera set up like we do here, but you just want to sort of work on these fingers. And so you can come here, use the magnifying glass, click on the fingers, it'll zoom in, but it won't actually change the camera. So by pressing escape again, you'll revert back to your camera position. I think this is incredibly useful. And then this here will flush all your texture caches and rebake them. In this next part, we're going to take a look at XPU, which is only available in the commercial version of RenderMan. Now, I know most of you might only be using the non-commercial version, but I thought I'd add XPU into this Kickstarter so it gave you a glimpse of what XPU can do. But please note that all the techniques and nodes that I'm going to show you from here on in also run perfectly well in RIS. So they're not specifically XPU techniques. So if you're on the non-commercial version, you can absolutely follow along as well. Okay, so let's have a look at XPU. And that comes with a few little caveats, which I'll talk you through as we go. So let me stop the IPR here, which is running in RIS. And if I stop it and I come up to the scene tab here, you can see that at the minute the render is set to RIS. And if I go ahead and I set this to XPU. Now the next thing I need to do is I need to tell XPU which resources on my machine to use. Because XPU is a hybrid renderer, which means that it can use all the resources of your CPU and all the resources of your GPU. So here, for instance, under the RenderMan preferences, you can see that we've got two options. We've got CPU, and that's ticked, and that means that XPU is going to be using all of our CPU threads. And I've also got GPU as well, and this shows you that I'm using my RTX A6000. And by having both of these on, it means that XPU is going to be using all of the resources of my machine, all of the cores and threads, and all of the GPU power. So now I just want to bring your attention to what XPU in this current phase is actually designed to be used for. So if I show you the documentation, you can see on this shader and look development page within XPU that there's this graph here. And this is meant to show you how XPU is supposed to be used. So in this phase 1 release of XPU, it's designed to be used as an authoring material and asset look development tool. So in the Pixar Studio, for instance, they use XPU when they're look deving all the assets that you see in all their amazing films, but they don't use the XPU renderer to render the final frames out. And you can see how this pipeline can be applied to something like Blender. So you would create your materials using XPU, which you'll get much faster feedback for. And you can see that here, that as I've been talking, this whole scene has now refined its render. So if you're working on a material library, say of golds and plastics and woods and glass and skins, then you would use XPU mode. And in the similar ways, we've got this kind of shader ball set up with a single HDRI, which is illuminating our scene. You would use this in XPU mode. And then what you do is you then save each of those materials out to RenderMan's preset browser. And then what you can also use XPU for is look deving single asset. So again, if this robot here was supposed to be used in a wider scene, you would set up a look development scene like I've got here, and you would use XPU to refine the shaders and the materials. And then you can then export this asset out. And then you would then import your asset into your wider scene or shot. And then your final render frames are supposed to be in this phase 1 development of XPU. They're supposed to be rendered using RIS. Now, that's not to say that you can't go crazy and wild and start pushing the boundaries of XPU and start creating full scenes within it. It's just that at the minute, XPU is in its phase 1 release and it's not necessarily designed to be used for final production scenes. But that's not to say that you can't go all rebel and push it as far as you can. But if you find some things don't work, then you'll know why. And you have to understand that more and more features will be added to XPU over time. Okay, so with that caveat, let's go ahead and start to look dev this robot even further. So a quick intermission here, and after recording the first part of this lesson, I noticed on Discord that there was a number of comments and questions about features like UDIMs, PBR materials, and bump to roughness. So I thought that what I would do is change how I was going to approach this lesson and actually address those questions in an aid to try and help new Blender users get up to speed when rendering with RenderMan. Okay, so here we have the same robot, and what I did is I jumped into Mari and I decided to retexture him. And I've simply used a PBR Metallic Workflow within inside of Mari. And very simply, I have two materials here. I've got this robot metal and I've got this panels. And so the robot metal here is what you can see on his fingers and on these mechanical pieces here. And this panels is the red outer panels which I've made. And then I have added some dirt over the top. So the 4 channels that I'm exporting out of Mari, and this is the same really for Substance Painter, and I'll show you that in a different lesson. So I'm exporting out a base color, which looks like this. And so that's the base color. I have my metallic, and then I have my specular roughness, which is this, and then I have my bump, which looks like this. So I've exported all these maps out of Mari as 16-bit EXRs, and the reason for that is that I kind of wanted the maximum visual fidelity. So once back in Blender, the first thing I did is I went to the Scene tab, and here under RenderMan Texture Manager, I loaded in all of the EXR files that I've just exported out of Mari, and then Texture Manager then converted those into .tex format. And the way I did this was I went to pick images. I selected the folder where I'd exported out all the EXRs. So here you can see all of the EXRs for the base color. And if I scroll down, you can see all of the ones for the metallic. And then here you can see all the specular roughnesses. So you all probably noticed that I didn't spit out a normal map. And the reason for this is that within Mari, I worked within the bump channel and I wasn't really working within normals. But the good thing is you can either convert a bump map or a normals map into a bump to roughness map. So here, for instance, inside this bump to roughness folder, you can see that I've got these 29 UDIMmed bump EXRs, and then the texture manager has converted these to bump to roughness. And you can see here because it adds this underscore B2R. And the way you do that is you select the bump maps within this list here, and then you then change this bump rough parameter. So you then specify whether the input EXR was a bump map or whether it was a normal map. And then the texture manager will then go ahead and convert all of your bump maps to this special bump to roughness map. So I just wanted to jump in here and clarify why I'm using the texture manager to convert all my textures in this manner. The reason is that I had a lot of EXRs to convert, and to save time in this video, I converted them all beforehand. So it just made life easier for me because I could select all the images, come back a few minutes later, and they were all converted and ready to go. Now you don't have to work like this. You can simply select the EXRs in the Pixar texture node and let the texture manager do its work in the background. So again, the eagle-eyed viewers of you may have noticed that actually I've applied a new material, and I was going to show you how I built it by just stepping you through what I'd already done, but I thought the best way to show you is actually start from a completely fresh material. So just coming up to the render properties here, you can see that I'm using the renderer and that's set to XPU, and the IPR rendering is set to Blender. So let's go ahead and press this blue button here, which kicks off the IPR within the viewport. And after a minute, you can see that it fires up, and it's not particularly inspiring, but let's go ahead and load in all the textures. So the first node I want to drop down is a Pixar Metallic node. So by pressing Tab, I start by typing PXR, and then Metallic, and then you see we've got this Pixar Metallic Workflow. And the next thing is asking me for a number of inputs, the base color, metallic, and also the specular. So let's drop in a Pixar texture node. And let's plug the result RGB into the base color. And now let's take this result diffuse and plug that into the diffuse color. Now, you can see here that it's gone pink, and we know why it's gone pink is because there's nothing in this file name box. So if I just select the texture here and I go to my source images, you can see that I've got 29 UDIMs, and all I need to do is select the first one in the list and press accept. And then it'll go ahead and load in all of the textures. But we haven't set the UDIMs up correctly. So if I just expand this out a little bit and I zoom in so you can see this clearly, you can see here that we've got base color.1001.exr. And the way that I set this up for UDIMs is I delete the UDIM name and I do this bracket and I type the word UDIM, which can be in uppercase or lowercase, it doesn't matter. And then once I press enter, and you can see here that the viewport within XPU is very, very responsive. So let me just scale that down a bit. Now the next thing it's asking me for is it wants a metallic map. So again, I have to type in a Pixar texture. And I do the same thing. And then so coming to the folder, I can then go to source images, and then I can find my metallic maps here, which it's got here. So I press accept. And again, I need to do the same thing. So I need to come here and I need to change this 1001 to bracket udim close bracket. And now what this has done is it's loaded in all the metallic maps, but I now need to take the output and plug it into this metallic part. And all I need to do is take the result R and plug that into this metallic parameter. Now what you can see within the Pixar surface is I've got two lobes that have been activated. The first is the diffuse lobe, and we can see that here because we can see our base color. And then the next one is I've got this primary specular. And what I need to do is I need to connect up the edge and the face outputs from the Pixar Metallic Workflow into the primary specular face color and primary edge. So I take the result specular edge and I put that here into primary specular edge, and then I then take the result of the specular face and I plug that here into primary specular face color. And now what you can see is that we've now plugged in our metallic map. And let me just tidy this up a little bit. So the next thing you would do in your standard PBR workflow is you would add in your roughness map, and then you'd also add in your normal or bump map. But we're not going to do that in this lesson. We're going to use the new and exciting bump to roughness node. So I will start by typing Pixar bump, and then here you can see we've got this Pixar bump roughness. And if I just zoom in on this, you can see that again it wants to know which textures we want to use. So if I just open up the file view and I go to source images, and then here within my bump to roughness folder, you can see here that I've already got my bump to roughness converted as I showed you earlier. And like all the other ones, we set the first in the list and I pressed accept. And again, like all the other UDIMs, I need to then replace this 1001 with open brackets UDIM, oops, spell that right, open brackets UDIM, close bracket. Now this is where the magic of the bump to roughness really comes into it. So it has a bunch of outputs, and these outputs are really going to change the whole way that this material looks. So the first in this list is it wants this result N, which is effectively the normal. And you can take that out and you can plug this into this bump. And the next thing in this list is it wants a roughness. And again, we take the output and we plug it into our primary specular roughness. The next one is result anisotropy. And then here you can see that it's begging to be plugged in there. So let's plug that into primary specular anisotropy. Then we've got two more things. One is we've got result direction, and then we've got this result NG. But we're not going to worry about this result NG. So the next thing we want is we want result anisotropy direction. And yep, all you need to do is take the output and you plug that into the primary specular shading tangent. So now what you've done is you've made your first bump to roughness node. So now what we need to look at here is these parameters here. So the first thing I need to do is I actually need to invert my bump normal. And so if I zoom in a little bit closer and let's look at the specular highlight on the top of the robot here. So you can see here that actually he looks much shinier than he did in Mari. And this is controlled by this base roughness. So if I start to increase this up, you can see now that what we're defining is that the base roughness of our specular is actually 0.365. So I can come down to something like 0.2, and now he'll become a bit more shiny. The amazing thing about the bump to roughness node, and so what it does is it mixes between bump and roughness depending on how close or far away from the object you are. So if I just get a grazing angle here, and then if you look at this scratches here that we have, now as I start to get in closer on our object, and I can go even closer, you can really start to see that we have all manner of things going on. We have this really interesting bump, and we've got our roughness, and the anisotropy direction is running as well. So if you were just using a normal bump node, as you start to go away from your object, you start to lose this refinement. But the beauty of the bump to roughness node is that as we start to pull out, you can see here that it's really retaining this detail. And you can try this yourself by plugging in a normal bump and a normal roughness node. And as you start to go away from the object, you would start to lose this detail here. And as I move even further, you can still see that we're really still seeing these scratches, which give the surface detail at very, very far distances. And again, once I start to zoom back in again, you know, we can really go very, very close to it. It's using all of the details that we've already painted in Mari. So again, we start here, and as we start to zoom out, now what's happening is it's starting to use less of the bump parameter and more of the roughness. And we're going further and further and further away, yet we're still retaining these details. And that's the visual magic of the bump to roughness node. And here you have a whole bunch of other parameters. You can control the gain. So if we want to increase the overall bump and roughness of our object, we can take this up to 2, or we can go to 5. And if we then want to start to bring down our base roughness, something like 0.1 to make him overall shiny, then we're starting to control it. If we want to have more bump, we can do this with our gain. So now he's going to be more bumpy. So we can take that down to something like 0.2, and now we're starting to lose that bump. But what it's doing is it still retains the roughness. So we have individual controls over how we want the roughness to be and how we want the bump to be. And again, we also have it for our anisotropy gain. So we can go crazy and really whack this up to 5. And now you start to see here, the scratches are really starting to drag those specular highlights out. And so I hope this has been a really useful introduction to UDIMs, the Metallic Workflow, and also the Pixar bump to roughness. Okay, so let's have a look at it before we start to wrap up this Blender Kickstarter lesson. And the way you start to doing your interactive render sessions to it is if you come to the Render Properties tab, and here you can say Render IPR2, and then you've got 2 options. You've got Blender, which is what we've been doing at the minute, and then here you've got it. So if I choose it, and then I come up again to the blue IPR button and I give that a click, and then I just need to come down here because I've already got it running. And after a few seconds, you'll now start to see that the interactive render, and so you can see here that the interactivity is actually very, very impressive. And actually this robot just doesn't stand still. He's actually got keyframes as well. So I can actually start to scrub through my timeline, and very, very quickly, the interactive session will actually update inside of this viewport. And there's a whole bunch of options inside of it, and I'm not really going to go through them now because you can go on the RenderMan Pixar website and have a look at the fundamentals, and there's a whole lesson on it, and you can also check that out on the YouTube channel as well. But one of the things I want to show you is the catalog, and if you just press C on your keyboard, what happens is that we've now got this series of images that you can see that happens every time you start and stop either a render or an IPR. And this is really useful because now what happens is that I can now start to skip back through a whole bunch of renders that I was already playing around with before I started this lesson. And the nice thing about these is you can actually save all these out. So you can go export catalog, or you can go export file. And actually it's a really nice way to work because you actually start to document your look, dev and creative process. And it has a whole bunch of other options here. And the one I want to bring your attention to is actually up here in Commands and under Bloom, which is a new feature for 24. And if I select it and I then go OK, what happens is that it now applies some bloom to my image. So this was what my original was like, and now this is it with some bloom. Okay, let's just have a look at a couple more things quickly before we finish this lesson, and it's all to do with rendering. So this option here allows you to render your still images either to Blender or to it. So let's just quickly render this robot to Blender. And I do this very simply by clicking this render button here. And you can see that it's going to be using the XPU. So if we just give it a minute, you can see the progress right down the bottom here. And then after a second, and there you go. And if we just come here and we go to color, then it's the same picture. And you can see that the 2 images correspond nicely. And again, I can do the same here by rendering to it, which we've just had a quick look at. And then again, we had a look at this. So this is how you render your interactive sessions to either it or Blender. This is how you render out your animations. So again, if I wanted to render out this 128 frames, which you can see on the screen now, I click the render animation button, and then I click external renderer. And what this does, if I fire this up, is it then starts this thing called RenderMan's local queue. And if I then come through each one, you can see the progress of what it's actually doing. So it's actually now starting to render out all of my frames. But the question you're asking yourself, and if I just come here and I go delete job, is where are the frames being rendered to? So if I shut this down, and if I come here to the output properties, and so this output path is where all of your Blender outputs go to. And if I open the workspace here, you can see that this is where my beauty is going to be spat out to, and then this is where my AOVs are going to. And again, you can set tokens here, like things like scene and layer. So I hope this RenderMan Kickstarter has been useful and it's answered a few of your questions. And I do recommend that you go back and watch the other fundamental lessons as well, because like I say before, they may be in Maya or Houdini, but actually the nodes are identical. And I think you'll learn a lot, especially about the Pixar surface and all the other material nodes.